So this session is going to be guiding you guys a little bit into how to identify a failure, the problems, causes, remedies, and eliminating those failures to kind of support your business processes in asset management, okay? I'm a big proponent of fundamentals. So some of the things that you'll see probably looks a little rudimentary, but it gets the job across to get you started on how you put your failure hierarchy together. Make sense so far? As he said, my name is Michael Guns. I'm a senior Maximo and EAM consultant with JFC and Associates. What we do is apply those fundamentals that I was talking about and give a holistic approach to asset management, failure codes being one of them. I listed my credentials here so that you understand that I've come up through the trades and I've gone through the maintenance and reliability community as a whole. So I know a building's assets from beginning of life until the end of the life cycle. The objectives of today's session will basically be giving you some of the high-arching overviews of failure codes and failure modes, what they entail, and how you can apply them. We'll look and develop some of the situational asset management awareness that you're going to need to apply those failure codes to your CMMS program. Putting it in, putting it on the work orders, and identifying the codes or the failures so that you can get rid of those defects. We'll do a little bit of awareness about eliminating the defects and what it causes them. With these causes and remedies, you'll apply those so that you can fine-tune everything and get down to the nitty-gritty of what's going on. And then the last thing, with some of these processes and strategies, you'll be able to align your business processes a little bit better. Kind of get everything together, okay? So again, I'm a big proponent of fundamentals, so definition-wise, failure. A failure is an inability of an asset to perform at its designed function. When you specify an asset at the beginning of its life cycle, when you define how you're going to put the building together and what that asset's really going to do, you have parameters that it's supposed to set by. With those parameters, you want to make sure that it follows that cycle so that it operates properly. If it doesn't operate properly, then you have problems within your facility that cause defects. These failure codes will align it so that you can identify those defects and perhaps maybe make specifications for like motors and pumps a little bit clearer and easier at the beginning of its life cycle, therefore eliminating the defect if possible. Things break all the time. No matter what you do, no matter how you do it, no matter what you maintain, you could possibly institute a failure if you over PM something or over maintain it. Some of the examples of failures, we'll go through this list so that you identify some high-level ones. These may change in your organization. You may find things that you want to report on a little bit clearer and be outside of this realm. But understand that at this point, the failure needs to be high-level. You don't want to get down into the weeds yet because that's what your upcoming problems, failures, causes, and remedies are. So electrical. Most things run on electric. You're going to have things go wrong with that electric at one point in time or another. It could trip a breaker. You could have a short, something like that. Ventilation, air handling units, fans, water would be pumps, pump motors. Maybe it's a sprinkler system that you're looking at. Failures associated with them. Fuel. Diesel engines for your generators, any kind of natural gas, you want to apply that to them. Locks and keys, obviously for all the doors in your buildings. Underground systems, you want to identify those because over time there may be failures that cause them and make bigger problems like some of the other ones. Heat, basically heating systems, very similar to ventilation except this is just geared towards the heat portion of it. And then fire. Fire is going to be an important one because of the regulatory bodies that you have to report to. They like failure codes because it gets down to the problem. And once you get that problem eliminated, it's better off for your EMR later on. So the problem, we have a failure, now we have a problem associated with that. So what makes a failure happen is your problem. Again, be simple on these. Get down to what you need to do, but keep it high level at this point. It's kind of, look at it as a step system. So some things that are easily identifiable: no power, lights are out, leak or a breach. You can see how these start to apply to the problems that we had beforehand, right? Flood, alarm, or hazard. Alarm or hazard could go for your fire systems, your heat systems. It could be just that you need to reset something. Maybe a setting was off. From there, what made the problem occur? It's your cause. So now these elements need to get into the weeds a little bit to identify some stuff. Focus in on exactly what that cause is and be concise with the description, okay? How is this going to help you to eliminate that defect? How is it going to give you information that you can report on to support your means? These are some examples of your causes. Trip breaker. In an electrical system, if a breaker trips, there's a reason behind it. That overcurrent device is developed and maintained so that it trips at a certain level, whether that be a short or an overcurrent situation. With that, you want to get down to that because that could cause a fire. Equipment malfunction. Obviously, something goes wrong and you're going to have that in anything. If that equipment is malfunctioning, it could be user error, something happening with that. Assembly and setup gets back to that specification and design period at the beginning of your overarching asset management cycle, right? And if it's not assembled right and it's not set up right, the parameters are lost and it's not operating at the specifications it was supposed to. Improper storage. Good example of this is a motor that's sitting on a shelf. You have rotating assets. That motor has to be pulled out, a new motor put in. If you're leaving it on the shelf and you're not rotating it, inside of that lubrication could gum up and not let that motor run when you put it into service. Improper maintenance, very similar, but improper maintenance could be that you're introducing failures. Inadequate design goes back to that specification period again, but you want to understand that if it is improper design, what was it? Did we do something wrong at the beginning stages when we designed it? User error, everybody makes mistakes. It happens all the time, right? And then end of life. There is end of life. Age is going to catch up to everybody. Doesn't matter what it is, assets, people, etc. So end of life is a good one to get down to, okay, what is this particular cause? Okay, you have your failure, you have your problem, you have your cause. Now, how do we fix it? The remedy. What you do to correct that failure is going to dictate how your defect is eliminated, okay? The fixes are usually a replacement. Something broke and we just replaced a belt or something like that. Maybe we replaced a shiv or a filter. You might have made a repair instead. Alignment, reset. I just went in and I reset the fuse, or I reset the parameter that was supposed to be happening at that particular moment. Adjusted something. I adjusted a thermostat because it was too cold in that room. Or you could possibly have no action taken. There are going to be those times where it just corrected itself. Now, even if it does correct itself, you want to get back and find out why it corrected itself. You don't want to just let it go because it could be a more catastrophic failure later on. So a sample list of failure coding, this is important to do for the roles and responsibilities of what happens with your work when it comes in, okay? You have to think about your intake. Is it with a dispatch office, or is it someone that is taking it within a shop, perhaps? Okay? That dispatcher has to understand what's going on by the description of that work and can apply certain failures and problems to that. If you create a matrix and identify specific things about those failures and those problems, they can look at that matrix and pick those particular codes and apply it to the work order ahead of time. This will be one less step that the mechanic and the technician has to do in the field when they're performing the work. Obviously, the mechanic or technician is going to be the SME, the subject matter expert. We want this person to be acclimated to what they're doing and be efficient at what they're doing. So if we can get these codes ahead of time, it makes it all worthwhile, okay? Your mechanic and technician are going to look at that cause and that remedy. They're going to look and see what's going on with that problem and if they can get rid of the defect. The whole point of this is to get rid of those defects and save some time and money. Once you have all this, you want to create a hierarchy, a classification structure that will support and roll up. I want to be able to see how they're applied and how they're laid out for my work orders, my assets, or even my locations. That way, I can go back and forth and see and report on, which we'll show in a little bit, how those are affecting my overall business processes. The aim of your organization is to try and get down to what the mission and vision of your organization is and how you're supporting your end user. All right? So let's take water. Water would break down as a failure into leak. From leak being a problem, we can look at the causes: bad device, perhaps an equipment malfunction, damage. People break stuff all the time, right? You could be in the middle of a mechanical room and accidentally step on something and break it, damage. From there, we're going to look at bad device and see what remedies we would have for that. Replacement, repair, or just adjusting. So once you get this laid out and your hierarchy is drop in, you can roll up or roll down depending on what's going on and report on that to see where your bad actors are. Once you find your bad actors, get rid of the defect. Understand your failure patterns, why they happen, when they occur. Okay? This is a chart from Reliability Web. It shows on the top side, the age-related type failures. On the bottom side, the random type failures. The ideas behind this are to see how your assets are reacting based on the failures that occur. First one being the bathtub curve. You might have some failures at the beginning of the life cycle of the asset. Everything works itself out as you find the defect and you kind of eliminate it, but at the end of the life cycle, they creep up again. Just kind of one of those things that happens, but over time, those age-related components break down. Very similarly with wear out, you could have everything specified and working at the beginning of the life cycle, but at the end of the life cycle, you can see there's an increase in failures. And then very similarly to that is fatigue. It could happen over time and steadily increase. So how are your failure codes applied to those to get you down to that resolve? Below that, you can see the random sides, the initial breakdown period. You can look at that as it happens very, very suddenly and over the course of the life cycle. When that occurs, maybe we need to look at the fact that we didn't design it properly for what it's supposed to be doing. Does that make sense so far? I'm going to skip the random one for right now and go to infant mortality. Infant mortality is basically when you design it, you set it up, okay? You have a lot of failures because maybe it wasn't designed properly or installed properly. It's usually installing that happens, okay? But then after those defects are fixed, the life cycle is good, and it probably lasts a lot longer. All right, and then of course, random. Failures are going to occur no matter what, and you won't be able to predict 90% of them. But if you use your failure coding to identify certain things, then that rate goes up. Failure analysis is key in all this. So like we were talking about below, you can see all your failures, and then above that are your problems. Now we want to get into the nitty-gritty to find out what those problems are costing us over time. It's important to understand the structure behind your failure codes so that you can report back to your executives so you can get more budget for your maintenance. If I can align this to say, okay, inoperable end of life is costing me a lot of money. You can see that by the chart, the big red box in the middle. Obviously, I have an age problem in my building. So how do we curb that? Now we can look at deferred dollars and correct our facilities condition index by budgeting that ahead of time and forecasting out when I'm going to budget that and spend it. You can also look at a tree map and find the bad actors readily and quickly. You see right here, inoperable is number 1. Leak and breach is number 2, just by the size of the box, okay? Great thing about this is your reporting structure can be done right in Excel. You don't have to get crazy with some kind of, Tableau or Power BI or Click reporting if you want something quick and easy. All right, and like we talked about, age catches up with everybody. So you have to look at that age component and find out exactly when those failures are occurring. Maybe we need to specify something differently. And it all comes out in your root cause analysis. Your root cause analysis should be done where? Okay, and what time does this happen with your work orders? Does it happen at the beginning or the end?
Rephrase the question.
So the failure cause analysis, when would you do it?
After you fix the problem, as soon as possible.
Right. So it's an after the fact, okay? You take all those failure codes into account so that you can identify it. Now we need to hone in on what we need to do to eliminate that defect. So very good. How do we do that? All right. I'm going to search for all the data. I'm going to identify those things within my failure codes that make that defect occur. And I'm going to define the problem. Once I define that problem, it could already be done because of the way that you set up your failure codes. Your problem's your first one, right? Then you're going to collect some data on that, identify what happened with the problem, the causes and the remedies. With that goes in identifying those causal factors. What happened to make that failure occur? Now I can work backwards and develop some recommendations on how I need to correct that defect. Then I can implement those recommendations and report back and track how those recommendations are improving the fact. Improving the asset life cycle, improving my maintenance life cycle. Am I saving money because I'm not sending somebody out a million times? Probably because you're eliminating the defect. A couple of tools that you can use for this are a 5 whys analysis. If you ask why 5 times, you should get down to the root cause. You should get around. Very similarly with the cause mapping, like that tree map that I showed you. You look at that causal mapping and identify where the barrier occurred, and then get rid of those defects. A Pareto analysis is good. 80% of the time, it gets right down to the root cause immediately. Most of your failures are because of age. So a good way to look at that is see what the 20% is that maybe aren't causing that. And then, of course, a failure tree analysis, fault tree analysis. Bring it down by that hierarchy and identify what's going on. So eliminating defects, it's a hard process, but it's also an easy process at the same time. And I know that sounds kind of counterproductive, but if you look at how you're actually maintaining your equipment, on the left-hand side, you can see preventive maintenance. And the bell curve that's going along with it, you can see the total cost, the prevention cost, and the repair cost, and how these particular pieces of work actually reflect that. So the preventive maintenance, you're looking at that, your total cost is probably a little bit higher, all right, with the blue line. Then the orange line, your preventative costs are very high. However, your repair costs are very low. Likewise, on the other side, your corrective maintenance, everything's very high. And your preventative costs are very low because now you're reactive. You're trying to get those corrections done, and that's all you're doing. So you want to get into that sweet spot, the optimal bubble. When you do predictive maintenance and when you apply your failure coding properly, you'll be able to identify things that you can strategically do to get rid of those defects and put yourself in a very good combination of corrective and preventive. Does that make sense? The object is to get the best return on your asset possible. I want to look at my costs like we were talking about, okay? And the average total cost of the assets, if we divide that into the net income of your business and your buildings, you'll get the total return on the asset. Very similar to a return on investment. If I can meet all these objectives, now the aim of my organization, my mission and vision statement, okay, I'm meeting that criteria. I'm also meeting the criteria for my service level agreements with my end users and keeping those assets up and running as best I can. The objective of failure codes is effectiveness up, downtime down. We want that asset running as effectively and efficiently as possible for the life cycle of that piece of equipment. The best way to do that is to look at your failures and get rid of them. So we've set up the structure to identify those failures, what causes them, what we did to fix them. Maybe it's a training piece that we support our folks with so that they understand this and have more buy-in. Once we do that, you can see most places are in that high level, high maintenance, low ROI. So I'm doing a lot of maintenance, whether it be predictive, corrective, or anything else, and I'm not seeing any return for my money. Okay, it's very low. Most cases you see are this thing doesn't work right. So in the middle, on the bad and better side, you can see I have some high maintenance, high ROI. So I'm doing a lot of maintenance, but I'm getting some return back on my investment. Opposite that is low maintenance, low ROI. So I'm not doing a lot of maintenance, but I see my costs rising exponentially. Not getting return on there. The object is to get to that low maintenance, high ROI. I want to do the strategic maintenance, which is going to increase my return on my investment. I'm going to lower my costs. I'm going to apply time and get time back because now I'm planning my work around my failure codes and correcting them so I don't have to go back again. All right? So, you tell me, okay? We identified some high-level failure modes. I gave you a list of some potential ones that you could use within your organization to get a start. You'll probably have to expound on that as you go. You can create certain failure modes and failure codes based on the level of intent of the design of that equipment. Most manufacturers will give you some failure codes associated with what's going on in that piece of asset. We created a little bit of an awareness on how to work within the failure code to get rid of that defect. And then the situational asset awareness, I think we kind of looked at that a little bit more on how I can get my return on investment, how I do my maintenance. If I can get rid of that defect, my maintenance is going to be better and I'm more strategic in what I'm doing. And then, of course, the final thing, aligning the business processes. Within your organizations, get buy-in. Get buy-in from your maintenance staff, get buy-in from your end users, and have them as part of the process of you creating failure codes. Because they're the subject matter experts. They understand what the equipment does. How I work on that piece of equipment is going to affect a failure. If I can do it better and easier, and now I can report on it, they're part of the process, and it's better off. I listed a couple references here, very short and sweet. The biggest thing with references is you can take a look at them and see some different things that you might not have seen in this presentation. And with that, I want to say thank you. The QR code will give you my contact information, so if ever you need any kind of information or anything like that, I love talking about this stuff. I love to teach the fundamentals, like I said at the beginning. The fundamentals are very key because if I do everything the way it should be, or identify the easy things to get my folks doing their maintenance the right way, now it's going to save me time and money in the long run. Any questions?
Using Riga?
Yes. Yes. Now, one of the things that I kind of talk to folks about with Tririga versus Maximo, Tririga is really a space asset management, whereas Maximo is the equipment management, asset management. Does that make sense? Now, you can integrate the two of them, and you can have those failure codes go back and forth between the two softwares. Now, you can look at your space.
Through API?
Yes. You can look at your space and how the assets are affected by that space. Any other ones?
So, question.
Yeah.
So, once you have those failure coding established, as you say, we have the basic ones, and then we let the SME keep populating those.
Mhm.
What would be the low-hanging fruit that I can present to the stakeholders, to the plan manager, like these are the benefits that we're going to get once we get the failure coding established?
It's a good question. So ease of, what is the low-hanging fruit of the failure codes, correct? What you're going to be looking at is the simple natured things. So start looking at the things that break down regularly, okay? Identify those first and identify the failures associated with them. That list of failures that I gave you as the holistic approach, 90% of the work that you do will fit in those categories, just with that list I gave you. So if you align that a little bit, now you can start focusing in on those low-hanging fruit things like, okay, that's breaking a lot. Let's look in that. Let's focus in on that. But that also happens over here. So now it's a similar failure.
So it helps you connect the same condition at different assets.
Exactly.
So you narrow down your root cause analysis to better affect more than one asset.
Exactly.
Okay.
Yep. And to that note too, don't create a million of these. You don't need need to get super crazy with this. The beginning part, the failures, there's like 12 of them. That's all you need, really, because work it backwards and look at the failures that you occur, and I guarantee you by the time you get to the cause, it flows, and you'll find out what's going on with it. Your causes and your remedies, be strategic in what they are. They have to mean something to what you're reporting against so that you have that, that outcome, okay? And what savings you're getting from it, all right?
Well, the way we approach it is through facility condition index.
Mm-hmm.
So that total deferred maintenance divided by the replacement value.
Yes.
So the lower the FCI means the better.
Mm-hmm.
So you tackle those higher FCI, prioritize and put money on
Right.
so that you have a lower FCI.
Yeah, I'm glad you brought that up. So your facilities condition index can give you a lot of bandwidth when you're trying to budget for repairs. So if you have a high deferred maintenance component and you can apply these failure codes to support that, it's like a loaded gun. And basically you're going to get the budget because you've already identified all the heartache in between. So that facilities condition index, as you stated, the lower, the better. I have an example with the University of Delaware. I used to work there, and one of our buildings had a 27% FCI. Basically, you should have tore a thing down. So that failure mode that's aligned with that building, once we started reporting on it a lot and looking at the failure codes, they were like looking at, why can't you repair this? Because the age is there. That building should be raised, build a new one. And now we had something to go back on to support it.
Is there like a certain size of, I mean, there's obviously a cost for implementation with these strategies.
Mhm.
Is there a ideal size that you think is most effective for your client to get started with these strategies? I mean, it has applications for every single, like a residential homeowner could benefit from these practices.
Yes.
To be quite honest. Is there a price or a certain size client or a price point that you would say like, hey, like, this is where I think it's most effective from here and up with your company? Or
Yes.
You know?
The great thing about failure codes and reporting is it can be applied across the board. And it's relatively inexpensive, if not no expense, because you can apply these or create these failure codes yourself. If you need help with it, obviously, with consulting firms and that kind of thing, obviously there's going to be a price there. But if you look at what caused that failure, or look at that failure and kind of do the 5 whys. Why? Why did that happen? All right, why did that happen? Like, you can do that basically with yourself or a couple of people. If you're trying to nail that down and keep the costs low, make sure you make a small committee. Don't make it 12 people. It should be like 3 at tops. And you do a why analysis there and say, okay, the first why, second why. And if you do that, then it's within your organization, so the cost is low, if not anything. It's just going to be the time of the folks to actually get down to the nitty-gritty of what's causing that failure, so you can get rid of it. Did I answer the question?
Absolutely.
All right.
Thank you.
Appreciate it. Thanks, guys.